share the content. So same for good for and good to later show the problem first and explain slightly, and so they show your solution. So I ask good thing to show the problem here and can explain the problem slightly, and so they will understand what to do for you next.
Okay, this is the second question, and the question is that we need to.
Oh, sorry, it should be the. Oh, I ask you to emphasize second or the third one.
Yeah.
So this is the third one. Sorry.
Sorry, the third one. So we need to denote the normal distribution. So we need to verify the x can equal to this function, and if only if x minus gamma can equal to this function too.
So here the mission for you x follows log normal, and then we want to check x minus gamma follows log normal again, but we don't have the same parameter. We have another parameter. Okay, so go and check it.
So this is our solution. So first we use the forward derivation, so you can see we can first one is assume x is follow this LM function. So we use the definition of the PDF x is given by this function. So we use the new variable y. So y is equal to the x minus gamma, and we transform this from formula to the y minus gamma equal to the x. So we use this new formula into this PDF of the x. So we have this.
So forward direction here, you try to substitute variable x into the original function log normal. And finally rearrange, so you have the new formula. And this formula you find it is a log normal distribution again.
Yeah.
So that's why you have this log normal.
Yeah.
Okay. And how about half of the solution? Reverse direction.
Yeah. So we use the second solution, reverse direction, to assume this function is verified correct or not. So we use the y is equal to the x minus gamma. We follow this function, and we have this PDF y. So we keep the x is equals to the y plus gamma. So we had a substituting function like this. So this function is match the PDF for the error function. So this is the verifying the problem statement. Yeah, I think this is our result.
So in fact, reverse function, you can go in a reverse direction. Actually, it's true. So that's why we still have the result. The original one follows with those parameters. Okay, that is this is problem 3A, and the solution provided by group 3. So any question from the other members? So Darwin, okay, acceptable, and Alice, acceptable by you, right? And you, okay. So that's it, and thank you. And right now we have the discussion about 3B by group 4. Group 4, share, and once ready, then you can present.
Let me just share our screen.
Yeah, that's true.
Right, so today we're going to talk about the 3D solution, which is pretty much, I didn't, because it's an iPad, so I can't really do anything, but so for the continuation for the 3A question is that we want to show that on fixed non-value of gamma, the MLEs of mu and the standard deviation of the log normal distribution are like that. So why is it like that? Yeah. So in here, we can assume that the log normal distribution is indeed a normal distribution to begin with, but shifted because we have the gamma term in here. Is gamma term. So we still have the mean and variance normally. We just have the gamma term in here that shifts the distribution. So which is pretty much, let's say we have 0 and x in here, and then we have the gamma in here, and then we have the x plus gamma in here, for example. So what we can assume is that we can just simply go with the regular mean, and also finding this is the standard deviation, not the. If we just move this, it becomes variance. And because this is just shifted, we just shift the xi's with the shifted with the shift term in here. Sorry, with the shift term in here. So yeah, there's technically nothing else that we can do. We just need to shift that by gamma, and then that's it. That's pretty much the mean and also the standard deviation of the distribution.
So finally, you are asked to have the arithmetic one. So I didn't see you can have the arithmetic notation. So and you have some bubble correction because we have an arithmetic one. You can check from your problem. We have an arithmetic, for example, hat, mu hat, and sigma hat. So can you show some of the hat, mu hat, and the sigma hat first, and so that we can have some further description for your problem?
Let's check on this.
Sure.
We wrong. We write it wrong.
So you can correct it directly, no problem. So originally you should have a mu hat and sigma hat.
Yeah, we forgot to.
Okay. Well, so this is the solution provided by Gufo. Any questions? Are we? Yes or no? If yes, provide the possible question to Gufo.
Yeah.
You can speak up.
Yeah, I was expecting to what I was starting from the. I was expecting the answer to be proven from starting from the likelihood function and then finding them any, then prove that the answer provided in the problem will be the same. Or either he has to show the log normal without shift to show us how the data are shifted by gamma or not. But this is a kind of simple substitution to the data pointers. Actually, he just simply shifting the data pointers by gamma. Then he said that the maximum likelihood function is this one and this one.
Sure. So now we expect to have some derivation, then we can continue to have some further results of this problem. Just a suggestion.
Suggestion.
So any question else? If no, right now, let us move on and ask good to have further presentation and share.